We're going to finish up this section by talking about the intermediate value theorem. And the intermediate value theorem is placed in this section because it has to do with continuous functions specifically. And here's what the intermediate value theorem says. If I've got a function, this is going to be a beautiful picture, as I'm sure you can see. I've got a function, it's defined, it's continuous between a and b, again on the closed interval ab. And notice that f of a does not equal f of b, meaning I don't have a graph that looks like this. I've got some distance between them, either a is greater than b or b is greater than a, or f of a is greater than b, f of b is greater than f of a. You get the idea. Essentially what we're saying, if k is any number between these two f of a's and f of b's, this is f of a, this is f of b, if I've got some number k in between those two values, then there's at least one number between a and b that we call c that gives me that f of c is equal to k. It's kind of a silly little theorem, but essentially what it does is says, hey, because it's continuous, we know that there has to be something in between those two values. There has to be something in between that will help it take on the function in between f of a and f of b. So here's an example of that application. Consider a person's height. A girl is 5 feet tall on her 13th birthday and 5'2" on her 14th birthday. What does the intermediate value theorem tell us? That at some point there must have been a time when she was, say, 5'1" or 5'1½". She didn't just skip over it. She had to at some point been that height exactly, because 5'1" is between 5 feet and 5 feet 2. You get the idea. So again, what the intermediate value theorem is telling us is as long as f of x is continuous on the closed interval and f of a does not equal f of b, and k is some number between f of a and f of b, then there's some number c that will give you that value of k. If we do f of c, we're going to get k. Now, what is the point? Why is the intermediate value theorem ever going to be helpful to us? Well, because it can help us to locate zeros in the function that are continuous on a closed interval. And here's what I mean by that. Let's say I've got a function and I know, let's say a is up here. That was really bad. So a and b, so this obviously is f of a. This guy down here is f of b. So I don't know what this value is, which would be the 0 of my function, but I do know that it has a 0 in the interval from a to b. And how do I know that? Because of the intermediate value theorem says this guy is positive, this guy is negative. It makes sense that it's going to, because it's continuous, at some point have to cross the x-axis, and so at some point c that we don't know the value of, we're going to get that f of c is equal to 0. And again, not that my drawing on the last page was lacking in any way at all. Here is a much clearer example where we can see we've got a continuous function, f of x equals x cubed plus 2x minus 1. I have graphed a portion of it for you here. And again, I can look at this open interval from 0, x is 0, to x is 1. And I can see that the f of 0 is -1, f of 1 is 2, because this one is negative and this one is positive. Using the intermediate value theorem, it follows that at some point between 0 and 1, some point between there, the function is going to have to cross the x-axis. There's going to be a 0 somewhere in the interval from 0 to 1. So again, MA205ers, I've loaded 1.4 continuity worksheet into the practice section of your OneNote notebook. It's not graded, but it's great extra practice. If you take the time to complete it, I will take the time to provide feedback for you. But I won't just provide a key if you're not putting in that effort. I suggest working on this with your classmates. You can schedule a time in Teams. You should be really good at that by now.